Segmenting networks with VLANs, the witty way. In a previous video, I explained the similarities between the functions of a switch and the switchboard operators of the late 1800s. Switches make intelligent decisions about where to flood, forward, or filter frames. These decisions determine the logical connections created between all the ports. Switches are a layer 2 device that operate on MACs. This makes the logical connections layer 2 connections. Networks are more often than not utilized by users that are bound by different requirements. These requirements may be security or regulation-based, and which may lead to a need to segment the network. This is now the case, as our hosts are part of either the finance or sales department. The requirement is that the host and sales have no logical reachability to the host and the finance department. This means no IP connectivity at layer 3 and no layer 2 reachability. We could just call the switch operator and ask the connections that be made between certain ports, but how would she ensure she remembered? The easiest way would be to label the ports in some way. Like this. The ports for host A and host D are marked green, and the ports for host B and C are marked purple. The rule is now that no connections may be made between ports of different colors. Let's test it out. Host B sends a broadcast frame. The switch processes it and determines it must be flooded out all ports and makes the logical connection to host C's port. The frame is forwarded on that connection. No other connections are made. No layer 2 reachability means no layer 3 connectivity. The broadcast is possible. In networking, the construct that serves the purpose of the colors is called a Virtual Local Area Network, or a VLAN. With VLANs, we are able to logically split the switchboard. It gives us the same effect as having physically isolated switches. At the physical layer, the hosts are connected to the switch. At layer 2, the data link layer, the hosts are logically isolated like this. Each is a separate broadcast domain because the broadcast only reached hosts connected to ports with the same VLAN assignment. At layer 3, the network layer, the hosts still believe they are attached to the same network and assume layer 2 and layer 1 reachability. Any packet sent will be unable to bypass correctly implemented layer 2 segmentation. It is now time for the lab. If you haven't already, head over to my webpage, wittynetworks.net, to download the associated packet tracer lab. First, we access the switch. We want to check the MAC table. We can see that there are no entries, which is to be expected. The hosts have not yet communicated, meaning no frames for the switch to learn from. To easily get all the hosts to generate frames, I will send a ping to the broadcast IP of the network. This is the 10 network, signified by the /8 CIDR. This would make the broadcast 10.255.255.255. I start the ping and you can see the generated frame. The frame has flooded out all ports because it is a broadcast and will be sent to all ports in the same layer 2 domain, also known as a broadcast domain. I log back into the switch to again view the MAC table. The port location of each host has now been learned and annotated. As we can see here, all the ports are associated with VLAN 1. This is the default VLAN assigned out of the box. Let's see if there are any other VLANs. I issue the show VLAN command. It shows 1 as the default, along with 4 others, 1002 through 1005. These are legacy assignments and are unusable. Currently, all the ports are assigned to VLAN 1. To implement layer 2 segmentation, we must change this. We create VLAN 10 with the VLAN 10 command. We recheck the VLAN table and see that VLAN 10 is available, but no interfaces are assigned. I want to make the same config change to multiple interfaces, so I issue the interface range command, followed by the interface numbers. The command to make a VLAN assignment is switchport access VLAN and the VLAN number, 10 in this case. Had the VLAN not been made with the VLAN 10 command, this command, switch port access VLAN 10, would have created it. We check the VLAN table again and see that ports FA0/1 and 3 are now associated with VLAN 10. We can also issue the command show interface status to view the operational status of switch ports along with the VLAN assignments. Assigning the ports to new VLANs has purged the previous information. The MACs need to be relearned. The network has not changed, so I use the same broadcast ping. The broadcast only goes to host D, which based on port assignment is part of VLAN 10. The ports connected to hosts C and B, which are still assigned to VLAN 1, do not receive the frame, even though it is a broadcast associated with their network. You can see that the MACs for host A and D are now associated with VLAN 10. We try the broadcast from host C and see similar results. Only the port connected to host B and assigned to the same VLAN, 1, receives the frame.